So let us consider this question. We have to form a partial differential equation by eliminating the arbitrary constant. Z is equal to xy plus y multiplied by the root of x squared minus a squared plus b. We have to eliminate this arbitrary constant by forming what? A newly partial differential equation. Remember that the arbitrary constants we have there is a and b. That means we are going to differentiate two times, whereby we are going to differentiate partially with respect to x and as well partially with respect to what? With respect to y. So let us consider the given equation. Z is equal to xy plus y root x square minus a square plus b. Let me consider this as equation 1. Then I'm going to differentiate partially with respect to what? Well, with respect to x. Differentiating equation 1 partially with respect to x. If I differentiate z, I'm going to have the derivative of partial z all over what? Partial s is equal to. I'm differentiating x here. If I differentiate x here, I'm going to have 1. 1 times y, I'm going to have y. Plus, if I take x here already, differentiate y, I'm going to have what? 0. Then take y again, then differentiate x as 1. Plus, I'm going to take 1. This is a product. This is our u, this is our v. I take u, I want to differentiate with x squared minus x squared with respect to x. What am I going to have? We can apply chain rule to this. What are we going to get? If I have x squared minus a squared with x squared, I will just let u x squared minus a squared. Remember that we are differentiating partially. So if I differentiate u with respect to x here, I'm going to have 2x. ODE also work for PDE as well, but in PDE we only consider the what we are differentiating with. It means minus a square. A is a constant. I'm going to have 0, so I'm going to have 2x. So from here, I can say this one is y. Our y is equal to, what's our root? X square minus a square is u. Remember that in lots of indices, if I have a square root, I can write x square minus a square as half. So it means u half. If I say dy all over du, that shows that I'm going to take my half. My half will multiply everything here. U half then minus 1. I apply a product rule formula for this. That is 1 half the power of u is half. Then multiply everything. U half then minus 1. Then half minus 1, I'm going to have what? Minus 1. 1 over 2 u minus 1 over 2. I'm going to multiply 2x, then the answer I'm going to multiply it together. What give me u when I differentiate? What give me y when I differentiate with respect to u? So it means if I multiply 2x times this, I'm going to have 2x times 1 all over 2 u minus 1 all over 2. Remember that half is a square root. Then is what? It's affecting what? It's affecting u. What's our u? X square minus a square. Then what do I have here? 1 over negative minus 1 over 2, that is 1 over lots of indices. Then multiply by what? 2x times 1 over 2. That is what? 2x times 1. I'm going to have 2x. Then what do I have here? I have what? 2. So it means I have 2x over what? 2. I can easily cancel out. 2 is going to 2 here 1. 2 into 1. So my answer is what? X over root x squared minus a squared. So it means when I differentiate this, I have x all over root x squared minus what? A squared. That is my answer. Plus, if I consider this, if I take this x square minus a square, then if I differentiate y here with respect to x, that is a constant. When I differentiate a constant, I'm going to have 0. Plus b also is a arbitrary constant. If I differentiate arbitrary constant, I'm going to have 0. So what's my next step is what? Please remember that the partial z, partial s, the notation for partial z, partial s is what? P. So whenever we say partial z, partial s, we're going to write it as what? P is equal to y plus y times s. I'm going to have xy all over what? S square minus a square plus times 0, everything will be 0. So it means when I differentiate equation 1 partially with respect to s, I got this. So I make this one to what? To be equation 2. Next is what? To differentiate again. To differentiate equation 1 again partially with respect to y. Why? Because we have an arbitrary constant, which is what? 2. Differentiating equation 1 partially respect to y. So it means if I have z, if I differentiate z, I'm going to have partial z over partial y, or the z over the y. I'm differentiating with respect to y. If I differentiate x here, if I take x here, if I take x here, differentiate y, I'm going to have what? 1 with respect to y. Plus, if I take y, differentiate x, I'm going to have 0. Everything will be 0. It's a product. Plus, I take y here. Y is a product because y times this. I take y, differentiate x squared minus a squared. With respect to y, I'm going to have 0. Remember, in partial differential equation, whenever what we are differentiating is not with that respect, it's going to be a arbitrary constant. When it's going to be a constant, and we differentiate the constant, we're going to have 0. Plus, take root x squared minus a squared. Then differentiate y here. I'm going to have what? With respect to y, 1. Plus what? If I differentiate arbitrary constant b, I'm going to have 0. So therefore, the z, the y, the notation for the z, the y is what? Q. I'm going to have q is equal to what? X plus root x square minus a square, because plus 0 will give me 0. Y times 0 will give me 0. So this one, I can label this one as equation what? Equation 3. What I will do next is what? I can make q, I can make root x square minus a square as a subject of formula. But if I make it a subject of formula and bring it and substitute it into equation 1, is going to go. But what we have here, we have a B. Our B here is not affecting with any other. It's not here stand alone. It's not affecting anything here. So it means what am I going to do is what? I will take P and Q here, because this B is nowhere to be found in P in equation 2, and it's nowhere to be found in what? Equation 3. Then if I'm doing a partial differential equation, I'm forming a partial differential equation that I cannot easily remove when I substitute into the given relation or equation. I cannot remove that arbitrary constant. It means I'm going to what? Consider equation 2 and equation 3, whereby making equation 3 the subject of formula, then substitute it back into equation 3. Suppose our B is here, I can make B as a subject of formula. Then I will now substitute what? Our x square minus a square. I will substitute. I cannot make x square minus a square subject to formula here. Why? Because if I do that, I substitute it into this equation, I'm going to be left with b, and there's no way I can eliminate b other than what? Considering what? Equation 2 and equation 3. So from equation 3, for equation 3, I can make root x square minus a square subject to formula. So I'm going to have q minus x is equal to root x square minus what? A square. Then what am I going to have next? What am I going to have next is I can label this, I can call this one equation 4. So in equation 5, in equation 2, I can write p minus y. I can take y to here. I'm going to have p minus y is equal to what? Xy all over what? Root x square minus a square. Since I've made it root x square minus a square as subject of formula, then I'm taking q x to what? Q. So that's why I do it to y. I'm taking y to what? To p. So in equation 2, I can substitute equation 4 into equation 2. Substitute equation 4 into equation 2. So what am I going to have? What is my equation 4? My equation 4 is this. Whenever I see q minus s, I'm going to put what? Root x square minus a square into what? Equation 3. So our equation 2, our equation 2 is p minus y xy over root x square minus a square is what? Q minus s, q minus x. So you can see from here, what am I going to do is what? To cross multiply. If I cross multiply over 1, I'm going to have p minus y, then multiply by q minus x. If I cross this one, is equal to what? X1 times 1 xy. So let me open this bracket. P times q, pq minus ps. P times q, pq minus what? Ps minus what? Y times q, I'm going to have yq minus what? Minus times minus is plus. Xy is equal to what? Xy. So you can see from here that our pq minus ps minus yq plus sy is equal to xy. You can see that as I'm solving the equation, there's no a here, there's no b here. That's the way we can do it. So what am I going to do is that I have xy here. I can take all this second term, third term, fourth term to this right hand side. So I'm going to have pq is equal to xy is here before plus px. Take this one to here, I'm going to have plus. Minus is going to change to plus. Plus what? Yq. The plus sign is going to change to what? Minus what? Sy. We have xy already here. Take this one to here, plus x plus px. Take this one to here, plus yq. Take this one to here, minus xy. This is plus xy minus sy. I'm going to cancel it out. I'll be left with what? pq, pq, pq is equal to ps plus what? Yq. Which is the what? Which is the what? Which is the required PDE? Which is the required PDE? Which is the required PDE? It means what? I've eliminated the arbitrary constant, whereby I get my partial differential equation as what? PQ is equal to what? PS plus what? YQ. I can write it as PS, PQ plus PS plus what? QY, either of the two. So I can another way I can write this one is, remember that our P is a what? Our P is what? There's Z all over what? The X. There's Z all over the X. I can write it as Q is equal to our P. What is our P? There's Z all over what? The S as well. As what? As X plus. Let's Q come first. There's Z all over what? The Y as what? As what? Y. So you can see I can write this as this. It's also the same. We know the notation for P for the Z over the S is what is P. Is either I write it in this way or I write it in this way is the solution to the PDE. So don't forget to subscribe to the channel so whenever I upload a new video, you'll be notified. Thanks for watching.